All right, so we just did example 2A, and we went through all three steps, and it said, okay, cool, it is a continuous function. Yeah, we got it. So with that, we're going to go on with B and C and see if they are continuous functions too. Yeah. So if they are, then great. If not, we'll just stop. So with this, when we get to our piecewise functions, and we're looking, not piecewise, but we're looking at continuity. If we go to step 1 and it does not work, you automatically stop there and say it's not continuous. If you go to step 1 and it works, you go to step 2 and it doesn't work, you stop there and say it's not continuous. If step 1 and step 2 work and step 3 does not work, you stop there and say it's not continuous. If steps 1, 2, and 3 work, then it's continuous. But all three of them have to work. Can't just be like that partial, like, oh, this works, but this doesn't work. Everything has to work. All three of them have to work out. All right, so with this one, let's go with step 1. We have our rational function that we've been talking about. So it says f of x equals x minus 2 over x squared minus 4. And with this part here, we're saying x equals 2. X equals 2. So if we're looking at that part and we're saying, okay, well, let's do this part. We know x equals c. So we'll do f of 2 for this function here. All right, substitute 2 in for x. And look what happens. Oh my goodness. We get 0 on top. We get 0 on bottom because let's do this really quick. Just to amuse everybody, appease everybody. You get 0 over 0. We talked about that yesterday. We cannot have that. So if that happens, it's indeterminate form, we cannot have this go on. So here, this function is not continuous. At x equals 2. All right, so just a couple of things to look at just to talk about why it's not really quickly before we move on to the last one. We automatically know, okay, if we take a look at the function, and before we even try to figure out what our vertical asymptotes and all that good stuff is, if we break down our denominator, it's x plus 2, x minus 2, difference of squares here. At this point, if we cancel things out here, we'll see that's 1 over x plus 2. So it's still a rational function there happening. So if we were to look at that part there, we should be able to see that there is a vertical asymptote at x equals -2. But if we look at x minus 2 equals 0 here, we say x equals 2. The factors will cancel out right here and right here. That means there is a hole at x equals 2. Because the two factors canceled out that make it x equals 2. So therefore, we know it is a hole, which is a point discontinuity for this function. So at x equals 2, it is not continuous because there is a hole there. And again, just pulling back what we talked about. Cool. All right. So we just verified again here that is not continuous at x equals 2. I think I said not continuous. Yep, its function is not continuous, it is discontinuous, and the hole or point discontinuity is happening here. All right, so we have a point discontinuity happening. All right, so let's go to the last part, which is C. And here we have everything set up, so we can go ahead and try the first part and then go for the second part and all the good stuff. All right, so step 1, again, with our piecewise function, says go ahead, and this actually kind of should be familiar for my students because we did this on the warm-up. We actually graphed this out, so we kind of already see what's happening. So here we're trying to say, okay, find the value of f of 1 because that's what C is for this function. And we have to remember back from piecewise functions when we graph this out and we figured out which function to use and everything. We know on this part here, that's where x is less than and equal to 1. So that's where it's equal to 1. So that means we have to use that second equation here to work it out. So if we use our second equation, we put 1 in for x. So we get f of 1 equals x, or f of 1 equals 1. So we have a value. We're good. Step 1 works. Check. Yeah. Now let's try for step 2 and see what happens there. Let's keep going, because hopefully we can get through all of this and get another one that actually checks out completely. So again, we already talked about 1. Go from left side to right side. So we're going to use those same values again. And here we had 0.9, 0.99, 0.999, and then 0.9999. All right, and then the right side, we're going to use those same ones we used earlier. So 1.1, 1.01, 1.001, and then 1.0001. And when we put in the calculator, we're going to try to figure out like what's happening. So first off, even before we do that, let's really quick, let's talk about this. When it comes to our functions here, looking at our number lines and everything, we know we're shading on this side because x is greater than 1. So it doesn't equal 1, but we're shading it. So that's on the right side of the graph. When it comes to the second part here, we have a bracket here at 1. We shade on this side here. So that's the left side. So when we start dealing with our tables here, for the left side, we're saying that's going to be x. This when x is less than or equal to 1. And for our right side, we're saying it's going to be 1 over x for f of x. And this is where x is greater than 1. So when we do this, we're going to put it into the table. We're going to talk about our limits and all that good stuff. I don't even know why I said limits like that. Limits. All right, so we do 0.1, 0.9, sorry, 0.99, 0.999, 0.9999. Yeah. And then on the other side, we do 1.1, 1.01, 1.001, and then 1.0001. So 3 zeros. Yeah. All right, so we put those in. And so when we put them into the calculator, we need to find the values for that, and actually hopefully they're going to the same number. All right, so with that being said, we're going to go ahead and put that into the calculator. All right, so we put it into the calculator. We hit we turn it on, hit y equals. We're going to do alpha y equals, and number 1 to give us our fraction bar. So alpha y equals number 1. We're going to do 1 over x. Remember, that's for our right side of the function. X here. That's the right side. And for our left side, we have x. Ooh, just x. Oh no, stop it. Just have x. All right, so when we do this second graph, come to our tables here. So we're going to take a look at y1 is actually the first function, which is this right here. So we have those values. Let's put those values in. So we do 1.1. Sorry, that's 1.1. It's taking a long time. 1.01. All right, so again, y1 is dealing with the first function, the 1 over x. y1 is 1 over x. And that's the second table here. So we put those values in. So we do 0.90909. Then we have 0.9901. Then we have 0.999. Sorry, 3 nines. And then 4 nines. 0.9999. All right, so we're going to put the other points in there for this right side. Sorry, for the left side of the graph. All right, so we put those values in from the left side. And again, we're looking at this part of the graph and this here, or the part of the table, sorry. So we put in 0.999 all the way to 0.999, the 4 nines. And then we have the y value there. So it's 0.9, 0.99, 0.999, then 0.9999. Right? So with this, as x approaches 1, we're saying y approaches 1. And as x approaches 1 on the right side, y approaches 1. So again, the left side is where we have the negative. So as x approaches 1 from the left side of f of x, we get an answer of 1. As we're looking at from the right side, we get 1. So they equal each other, which is cool, which we need. Right, so they equal each other, so 1 equals 1. So that means step 3, we said step 1 has to equal step 2. That's what we're hoping happens. And so let's go back to step 1 again. Very top. Step 1 we said was 1. Step 2 we just said was 1 right here. So that means the function is continuous at x equals 1. All right, so here, again, we found out that it's continuous. Yay! Woo! Let's go for it. And that's all this for continuity. That's all we're doing.